Welcome everyone. In this complete video, this is this is our first lecture of the series. In this video, from this playlist, we learn about the binary search. So without no further talk, I am starting my lecture. So before you starting, this is prerequisite of this playlist. You have a knowledge, you are familiar with the programming language. It can be C++ or Python or Java or something. That's it. It is the prerequisite of any programming, comfortable with any programming language. So throughout the playlist, I am using C++ as my primary language. Why C++? This is very common programming language among competitive programmers around the world. So I am using C++. Okay, great. So first of all, I can explain you what is the binary search. What is the binary search? So a book definition has everything, but I am give you the practical definition. It is nothing but a algorithm, but an algorithm but also a searching algorithm. So searching algorithm in a limited search spaces. Now I am explaining the overall definition. I say this is nothing but an algorithm. So what is the algorithm? Algorithm is a process to solve a problem step by step. Okay, I hope you understand about the algorithm. If you don't understand, search for Google. I say that it's a searching algorithm. What is searching? Searching like that, if you search anything in google.com or on other services, search engines, this is like a searching algorithm or searching something. This portion of this definition is important. They say that it is a limited search spaces. Actually, in the binary search algorithm, we decrease the search space. We have two pointers, left and right. Then we decrease everything. Okay. If you not understand anything now, so I give you a very important example which help you to understand this algorithm very well. So I give an example of a dictionary. Okay, I write the word dictionary. What's happening in a dictionary? Suppose you find the word, meaning of this word even in a dictionary. As a normal person, what you have to do? So remember, dictionary has a special property, which is dictionary words are sorted like A, B, C, D, E, F, and like this up to Z. You know it. So you, in general cases, you got you open the pages where all words starting with E, or sometimes you a page open and open, open and open, until suppose you generally you open the pages where all words with E, and then you find the meaning of the word which is even until you got the meaning. This is little bit time consuming because we use here a linear search algorithm. Linear search algorithm for linearly go through all elements until I get the wanted one. But if you think in terms of binary search algorithm, what's happened? You open the mid. Suppose, okay, I can add a shape. Suppose this is your dictionary. Okay, you target the word is even. What can you do? You open, you can make two parts of the dictionary. In this part you can say left, and in this part you can say right. Sometimes you can you rename it low or high, same thing, just in terms of naming. And this portion you can define as mid. So suppose here all words A, B, E sometimes, and in this mid you got the word M, and here all words until Z. So suppose you got the word with M. Now what can you do? You not need to find the word even in the right side, because of it is guaranteed in terms of dictionary that all words starting with E before M, not after. Here is the portion. So suppose this is M and this. So here you not get anything. You got your target here. This is guaranteed. Now what can you do? You eliminate the whole stuff. What is eliminating? You not consider it. You not consider it. Now you think with words A, B, C, D, E until M. Okay, not M. You need to not consider this before M. Okay, A, B, C, D, E, F, G, H, I, J, K, L, L until L. This is your consideration in terms of. Now again, you find the word mid. Suppose this is the mid. Now what can you do? All words after D, you have a chance to get the meaning of the word even. So now what can I do? I just eliminate this stuff. After eliminating, just think words until L. You got the mid, some points, but you got the correct answer in left or low part. This is guaranteed. Now if you understand the binary search now, it's okay, but you not understand anything now, so move on the next part, which I give you the real world example. Another example. Okay, I imagine an array which can have some elements. So this is one element, this is one element, and this is, And remember, the prerequisite of binary search algorithm is that all elements, all something should be sorted. So I write it 2, 4, 6, 8, 9. That's my case. I hope you already know about the array. 2, 3, 4. All the words I have written. And my target means something like 8. In terms of binary search algorithm, what we have done here, we have, suppose we declare an array 2, 4, 6, 8, 9. Okay, we consider it as mid. Now you can say how I calculate the mid. This is very simple. In binary search, we define it as a low or it's, and we set a pointer called high here, and we have a mid. And how to calculate the mid? Before calculating the mid, you just enter mid low plus high minus low divided by 2. But some people use this formula, low plus high. This is okay, but sometimes it causes overflow issue. So it is recommended use this formula to calculate the mid element. Okay. So what we done? We first set this pointer. So I can place it. This is the pointer 0. This is 1, 2, 3, 4. We have 5 elements. Okay. Great. We set it low and set it mid, and this is mid. Okay. First of all, our target is to matching with mid. First of all, so we divide the array and check that with mid element, which is the mid element. So we check with the mid element. If in our case it is 8, this is not check with 8. So what can we do? We just keep low in this side, in the right side, and simply overflow all stuff, eliminate all stuff, and we just think with these remaining elements. Now in the remaining element, we just have 8, 9, but we not remove the exactly, we just think with the element. You can consider it low and consider it high, and we can also consider it as mid. Okay, this is the sharpness of the pen. So this is 2 elements. Now we check with the mid. So it is checked with mid. So we return the value. If you not understand the code, on this stage of the lecture, now I write the pseudo code and the actual code in C++. So I'm starting the writing the pseudo code. So as a quick note, you can keep in mind that binary search finds the index of a target in a sorted array by shrinking the search space. Okay, you can keep this line on your mind. So we shrink the search space. What is the search space? We increase the low and high spaces. Suppose this is the low in the first step, the next step we make it low, or sometimes we keep it high, sometimes we decrease the value of high, we come ahead of mid sometimes. Okay, so I write the pseudo code. So the pseudo code is very simple as you think. So suppose you have a function which takes an array and you have a target of that. After that you have a low and set high as the length of array received as a parameter, and -1. Why -1? I will understand, because if you have an array of length 5, you not access the array length 5, you need to access, because array is start counting from 0. So this is the point. So after doing this stuff, I can write a loop for repetition, low and high. Okay, you just simply write a while loop. On the while loop, you need to calculate the mid. What is the mid element? So I just low plus high minus low divided by 2 for calculating the mid element. Okay, now in the raw binary search code you have 3 conditions. If array mid match with your target, all you have to do is equal mid plus 1. What we have done here? We just simply come ahead of mid. Before, so I give you an example. Suppose I have an array 2, 4, 6, 9, 10. 0, 1, 2, 3. Okay, so you supposed to get the 9, so you set it as a high and you set it as a low. So suppose you set it as a mid. Calculate. I give you example. So mid is not matched. In the first condition you have seen that mid, the target mid is not matched. So far what we have done, we just come low ahead of mid, so we place mid here. It means that we not counting this because we eliminate. Our counting is only with 9 and 10 after come low ahead of mid. Okay, that's interesting point. So I can remove this. All right. Okay, mid. So I give you a bracket. I have more conditions. If array of mid, is less than target. Think about it. Array of mid is less than target. It means after before array of mid, there is no guarantee, and this is not granted that target is existing, because array is sorted in non-decreasing order. Okay, so far we understand. We must ensure that we need to. Okay, we have a mistake that if we do that, we need to return the mid. Yeah, return the mid. Mid is mixed. Okay, this was my wrong. Okay, if I do that, what we have to do is low mid plus 1. If so, on that case, I just simply say mid minus 1. What we have done here, this is very simple. So I change the color. That was 3, 4, 6, 8, 11, 15. Okay, so let's consider in terms of x 1, 2, 3, 4, 5. Great. And suppose my target is 4. We define it as a high pointer and define it as a low pointer, and 6 elements. We set it as a mid. Okay, so our target is 4, but mid is not matched. Also, mid element is greater than target. What is defined? All elements after mid must be greater, because array is sorted. So all you have to do, we just move ahead of mid. So in this part we need to search. On that case, we point high before mid. How we do that? High is equal mid plus 1. Ahead of mid, in front of mid. Okay, so we point 6. Now in this stage, what's happening? Our search space decreasing. As you know, in the binary search algorithm, we are working with search spaces, manipulating search spaces. Okay, so our consideration with 4, 5, 6 and their indexes. Okay, 0, 1, 2. We not need to this eliminated. These are ignored. We're not counting with these elements. Okay, now in this state, all you have to do, to set it low and set it high and set it mid. Set it mid. Now all you have to do is, now we match with mid. So mid is matched. On that case, we return the value. So our focus is to return mid. First condition is correct. These are the complete goal. So I can remove this. That is why we do that. If anything not found, we return minus 1. Now we implement here the pseudocode. So I give you, I am writing the actual code, actual C++ implementation of this algorithm. Okay, so let's move on. You can use your favorite code editor, and you can use your favorite programming languages. Now in that stage, we move on our editor. I hope you see my Sublime text. I'm using Sublime text and I use C++ as language. So I'm using vector. I can create a vector. In your language, you can use something equivalent. vector. I use the length, take the length of the array. Also, okay, I use simple. I take the input. Okay, sorted is must. Sorting is must. So I can sort also the input. So what I should be done on that stage, I can sort. So before sorting, in your language you use personal choices. Okay, you can use your own stuff. So I use vec.begin, vec.end. Okay, and now we take the target also as input. We just taking inputs also. So I give some input. So suppose 6 elements. Okay, I can give you some distances. Suppose I take it 6, 4, 1, 2, 3, 1, 2, 3. Okay, I find the 7. Return the index. Okay, now I implement the search algorithm, binary search algorithm. So it just return the, so I give the binary search. Take the array as input. In the binary search, now what can we do? We set low as 0 index, and high as array of, okay, I need to calculate the size. Why, what we have done here, we just count, because array is counting from 0, so that for that reason I am -1. Now I set a condition. Okay, in this stage I'm calculating the mid. So how to calculate the mid? Low. I'm just calculate the mid element. Okay, after calculating the mid, if array of mid which returns the mid element, okay, if array of mid element equal to target, I just return the index of mid element. Okay, else if array of mid element is less than target, now low should be mid plus 1. Else if array of mid is greater than target, so I set the high as mid -1, come ahead, come in front of mid, and in the low come after mid. Okay, okay, you can use else if sometimes. If something not found, we got -1. Now I'm implement the search. If sending the array and target not equal minus, not return -1, I can say that this exists rather, I can say not found. Okay, now we have to do something like see how target is happening. So if you run the code, okay, array is not declared, so I need to pass the value. Okay, 7 is exist. Suppose I say random 10 not found. So successfully we implement the binary search. I hope you understand this video. In the next lecture we will talk about the recursion approach. Okay, recursion approach of implementing binary search algorithm. Thanks for watching. Bye bye.